Under fractions, ladies and gentlemen, please. Today would be a very good time to focus, because if I could narrow down one single thing why many people get many problems wrong from here on in, is because what we're talking today. Today's little subheading, those of you that like subheadings, is reducing them. Or the book usually calls it reducing, or you could also call it simplifying. Simplifying. Or you could call it, sometimes they'll say make and lowest terms. Lowest terms. All of these things kind of mean the same thing. And the basic gist of that is, because we talked about this before, if I had the fraction like 3/8, remember we talked about this whole times one thing where you can make a fraction anything by multiplying top and bottom by a fraction that equals 1, and you get 6/16. Those are the same fraction. They mean the same thing. If you ate 3 out of 8 pieces of a pizza, you also could have eaten 6 out of 16. Or, keep going farther, if I multiply top and bottom both by 3's, I would get 9/24. Or if I multiply top and bottom by 5's, I would get what? 15/40? Just take my word for it. The gist is this. If I asked you to give me 15/40 of a pizza, you may be slightly confused. Okay? And because any fraction has a countless number of equal fractions, we always want to give the fraction in what's called its very lowest terms. Okay? The lowest terms would be this. 3/8 is as low as I can go. If I have a pizza and I cut it into 8 pieces, I can't get any lower than that. If I took this pizza and cut it into 40 pieces and chopped it into 15, you could get that. Another example is this. Would I tell you to give me 7/14 of a dollar? If I said for you to give me 7/14 of a dollar, you'd have to sit there and go, 7/14 of a dollar? Well, I wouldn't say that, because there's a simpler way to say 7/14. 7/14 is the same as, Frankie, yeah, it's a half a dollar. A half a dollar, you understand, half a dollar is reduced. This is its lowest terms. This is reduced, it's simplified. It just makes it that much easier to talk about. So the question you're asking yourself, I know you are, even though you don't want to tell me it is how do you reduce? Question mark, question mark. I didn't hear somebody say that. How do you reduce? Oh, I'm glad you asked. It's very, very simple. To reduce, comma, you have to divide both the top, which we call the numerator, and the bottom, which we call the
denominator.
The denominator, as Schwarzenegger says. Denominator by the same number. I'll let you write that down, and then we will slowly talk about that. This is such an important thing. We'll go pretty slowly with that. And I'll use my 7/14 as an example. I will use my 7/14 as an example. And this is, again, another one of those places, if you don't know your multiplication tables, you are going to be in a small world of heritage. You just don't know those, because if you don't, then this will take you probably so much longer than it should or whatever. So what you do when you see a fraction, when you see like this fraction 7/14, you have to ask yourself, what number can I divide both top and bottom by? Another way to say that is, what common factor do they have? And you don't want to use 1, because you could always divide something by 1. If I divide 7 by 1, I get 7. 14 by 1, I get 14. It doesn't change it. But what number goes into both 7 and 14, Frankie?
2.
Nope, 2 doesn't go into 7.
I mean, 7.
7. So you would do this. You go divide by 7. Divide by 7. 7 goes into 7 once. 7 goes into 14 twice. And that's where we get the fraction 1/2. By the way, children, there's a little point to ponder here. The fraction 7/7 is the same as what?
1.
1. And when you divide by 1, what happens? Nothing. It's the same number. Just different letter numbers. It's just different digits. It means the same. So here we go. Let's try another one, just for fun. What if I have 4/6? 4/6 as a fraction is not reduced all the way. It can be simplified because some number can go into both the top and the bottom. What number, Andrew, can you take into both of those?
2.
Right. And if you see this problem on your paper, you'll write down 4/6. You'll write down my little divided by 2. Half of 4 is 2, and half of 6 is 3. 2/3 is the same fraction as 4/6. This is the simplified form of that. And on your papers, on your math papers from now on, you are going to have to start to reduce. Another example. 1/8 plus 3/8. If you add these two fractions together, what is 1/8 plus 3/8, Victoria?
4/16.
It is not 4/16.
Oh,
You don't add the bottoms together, right? 8 stays the same. If you write that as your answer, unfortunately from this point forward on a quiz, it will be wrong because you have to look at every answer now and say, is there some number that goes into both 4 and 8 that I could reduce this fraction by?
Yeah.
And you always want to pick the biggest number because these two actually have 2 numbers you could reduce it by, but you want to pick the biggest one, Trevor, which is?
2.
No, 2 is not the biggest.
4.
4. So I want to reduce them both by 4 because 4 is the biggest one, and I get 1/2. Now, let's say Trevor did what he said. If you divided them both by 2, what would you get? 2/4. 2/4 is reduced, but it's not as reduced as it can be. So even after you reduce, in case you made a mistake, you might want to ask yourself, well, here's 2/4. Is there a number that goes into 2/4? Yeah, you could reduce them by 2 again. And what would you get? You still get 1/2. It's just that you took an extra step. Either way, you get 1/2. You need to make sure at the end that you reduce it. How about this one? 12/18. 12/18. If I asked you to reduce that to its lowest terms, what can you divide both 12 and 18 by? Andrew?
6.
6. If I cut them both by 6, I end up with 2/3. Now maybe you were thinking, well, 2, because they're both even. If you do use 2, you get 6/9. But 6/9 can be reduced also by what number? What number goes into 6 and 9? Nathan? 3. And then you'd have to reduce it by 3 again and get 2/3. You always want to try and use the biggest one, that way you get there right away. But if not, then you have to take a couple different steps. Oh, what else do we got? How about this one? Well, here's a problem from the book. 1 1/8 plus 5 5/8. 1 1/8 plus 5 5/8. I'll have you do that problem for me right now. See if you get the same answer that I get. 1 1/8 plus 5 5/8. 1 1/8 plus 5 5/8. Remember, you always, anytime you see a fraction now, you always have to say, can I reduce that by something? And most of you are not going to get it right eventually. You'll miss one here and there somewhere. 1 1/8 plus 5 and 4 5 5/8.
6.
I did not say 3, Victoria. Thank you. Frankly, Frankie, when you add it together, I'm guessing you got 6 and 6/8, right?
Yeah.
But then you reduced it, Frankie, and got,
3 3/4.
well, not 3 3/4, just 3/4. You don't reduce, whole numbers don't get reduced. Whole numbers stay whole numbers. They will not change. You're not reducing those. You divide these both by 2, and you end up with 6 3/4. I should have said that. 6 3/4. How many people got 6 3/4? Whole numbers will always stay the same. You're never going to reduce a whole number. And one last one. We'll see how we're doing this one. How about 5 5/12. 5 5/12 minus, mind you, 1 1/12. 5 5/12 minus 1 1/12. Five 5/8 minus 1 1/12. Five 5/12 minus 1 1/12. Eddie Clark.
4 and 2 6.
Now 2 6 can be reduced more. But that's in fact what you got. 5 minus 1, you got 4 4/12, right? And then you cut those both in half and divide it by 2 and got 2 6. But 2 6 can still be reduced by, what number can you goes into both of those? 2 again. If they're both even, you can always cut them in half. So your answer is 4 1/3. Which you could have done right away by dividing top and bottom by 4. You would have recognized that right off the bat. Got 4. It takes a little getting